Alright, Smith here to review systems of equations. Now, last year in geometry you did quite a bit of systems of equations and we learned a bunch about them in Algebra 1. So let's do a quick review before we get started in Algebra 2. Now, systems of equations are two or more equations grouped together. Two or more equations grouped together. So, an example of one will be right here. Here's two equations. Now we're going to solve this one by graphing. So this first line, y is equal to x plus 9, our y-intercept of course is 9, and our slope is 1, which means that we go up 1 or right 1, or if we go down 1, left 1. I recommend making a bunch of points so when we find the intersection point, it's clear what it's going to be. So that first line is something like that. Hopefully you use a straight edge rather than something like I do. Then this one, you have a couple of ways to do it. One way you could do is by finding the intercepts, where you do 0 something and then something 0. If you plug in 0 for x, you get 3y. 3y is equal to 12, so y would be 4. And then in this one, if you do y is equal to 0, you get 2x equal to 12, that means x is 6. Now, the problem with this method is you got these 2 points. You don't really have a slope to really find the pinpoint of the intersection point. Now, this is a negative slope. From left to right is going down. And the rise goes up 4 over 6. Let's go 6 this way, which is negative 2/3. So like that, then you could go up 2, right 3, and you can find the intersection point like that. Of course, the other way is, instead of using the intercept method, is you could just go and solve for y, put it in slope-intercept form. So subtract the 2x, so you got 3y equals 12 minus 2x. Divide everything by 3, and you get y is equal to 4 minus 2/3 x. Our slope is still negative 2/3, just like we saw, but our slope is, or excuse me, our y-intercept is 4. So apply 4, 2, left 3, there it is. Anyways, the solution is the intersection point. And the intersection point is the point negative 3, 6. So our solution here is negative 3, 6. And that's my second bullet point here. The solution is the intersection point. And we should write that as an ordered pair, unless it's a word problem, which we'll talk about later. Anyway, so that's the gist of a system of equations, two or more equations grouped together. The solution is the intersection point. Now, the possible solutions to a system of equations, one is like we just saw. If you have one line and then you have another line that intersects that line, that's kind of a wavy line, sorry about that. That is one solution. And the one solution is, as we said, the intersection point. Well, what if the lines do not go and intersect? Something like this. Well, since the solution is the intersection point, if they don't intersect, that means there is no solution. Right? If the lines are parallel, then there's no solution. There's one other scenario you might recall. What if they are indeed the same line? What if they are the same line? Then that means there are infinitely many solutions. Why is there an infinite amount of solutions? Well, if the intersection point is a solution, they intersect right there, oops, right here, they intersect everywhere on this line, so that's why there are infinite amount of solutions. Alright, now let's get back into solving them. We solved the first one by graphing. That's our first method, graphing. There's two other main ways of solving. Another one is substitution. And the other one is called elimination, also known as linear combination. Depends on where you find you see it. Some places call it elimination, some places call it linear combination. Now let's talk about substitution. Substitution we are going to use when a variable is easy to isolate. Is easily isolated. For example, in this first example, y is easy to isolate because it already is. Y is equal to 3x minus 2y, or minus 2, excuse me. So then what we're going to do is go to the other equation and substitute into the same place. So what we have here is everything staying the same, 2x plus, but instead of y, we're going to substitute y. And what's going in for y? Well, the 3x minus 2. All right, now since there's only one variable, it's easy to solve. So 2x plus 3x is 5x minus 2 is equal to negative 7. Add 2 to both sides, you get 5x is equal to negative 5. X is negative 1. Now, once you have x, you still got to go back and find y. So I want to go back. It doesn't matter which equation you use, but I'm going to use the first one because y is just aching to figure out what its value is. So y is 3 times, well, x is now, x is now negative 1 minus 2. So y is equal to negative 3 minus 2, which is negative 5. However, remember, our final answer should be written as an ordered pair. So that would be that. Okay, so the second equation, the second example, we're going to solve this by substitution. The question is, what variable is easily isolated? What variable is easiest to get by itself? Top x, top y, bottom x, or bottom y? Now, bottom x and bottom y are both single. However, the x is the only one that is positive. So I would recommend getting the x by itself. X is equal to 8 plus y. Now, go ahead and press pause and finish this problem. I'll solve this myself really quick, and we'll see if we agree. Ready, go. So hopefully you came up with 3, negative 5. Now, one way that you can check your answer is to take your solution, plug it back into the original equation. To both equations, it should come out to be true in both places. 3 times 3 is 9. Negative 2 times negative 5 is 10. 9 plus 10 is 19. So that one worked. And then you got 3 minus negative 5, that's plus 5, so that's 8. So that is indeed the solution. Let's talk about elimination. Elimination is where you get the coefficients of one of the variables to be the same number yet opposite. So one positive, one negative, and then you're going to add up the equations and eliminate a variable. We can't solve this right now because there's 2 variables. So look for the easiest thing to get by itself. Now we could get p by itself, but we'd have to multiply both the top and bottom equations by something to get the same number but with opposite values. Instead, I'm going to eliminate the m. And to do that, I'm going to multiply the top by 1, but I'm going to multiply the bottom by not 3, but by negative 3. That'll give me 3m up top. 3m times 1 is 3m, but then it will give me negative 3m downstairs. So this is 3m plus 5p is equal to 19. That one stays the same, but the bottom is going to become negative 3m plus 6p. Multiply lottie-dottie everybody, even the constant at the end. So when we add this up, the m's cancel. You get 11p equals 22. P is equal to 2. Now, again, we got to go back and find m. We could go to the top or bottom. In this case, I'm going to use the bottom. M minus, well, 2 times p is also 2, so it'll be 4 is equal to negative 1. M is 3. So our final answer here is, put these, now if it's not in XY, put them in alphabetical order. L, M, N, O, P. So it's going to be MP. So 3, 2 is our final solution. Once again, go ahead and press pause. Try this one yourselves. Now, I'll give you a little hint. this case, we're going to have to multiply both the top and bottom by something. I would recommend looking ahead a little bit. If we try to eliminate y, what's the lowest common multiple of 7 and 9? It's going to be 63. We're working with some big stuff there. I wouldn't do y. I would do x. So with that tip, go ahead and try this one yourselves. So hopefully you came up with the answer 2, 0. Now, I multiplied the top by 2 and the bottom by -3. You could have done the top by -2 and the bottom by +3. No matter what, it still would come out the same way, 2, 0. All right, let's talk about special cases. Now, sometimes some weird stuff is going to happen. For example, this first one, I'm going to solve this one by substitution. Now, of course, we could solve by elimination, but just to review, I want to solve by substitution. So I'm going to get top x by itself. X is equal to 2 minus y. Right? So then I'm going to substitute that into this x. So that means that I have 2, I'm going to change the x, plus 2y equals 7. And 2 minus y is going in for x because that's what we're substituting. All right, so distribute. You got 4 minus 2y is plus 2y is equal to 7. Now, negative 2y plus 2y cancel, and we're left with 4 is equal to 7, which is false. That is not true. Now, here's what happens. If the variables eliminate, and you're left with a false statement, this is false, then that means this is no solution. And now, what did no solution mean graphically? If we were to graph this, now if you were to go ahead and get y by itself in each of these and graph these, you could do that on a ordered pair or on a coordinate plane or on your calculator, but you'll find these are two lines that are parallel. These are parallel lines. There's no solution because they are parallel. All right. Now, the other scenario is this one. This one, let's solve by elimination. If we were to eliminate, let's get rid of the x's. I have 3 and 6. I can make that 3 become a positive 6 by multiplying the top equation by positive 2. So this would be 6x minus 8y is equal to 10. Remember, hit everybody. And then the bottom equation is going to stay the same. I'm not going to change it. Negative 6x plus 8y is equal to negative 10. When I add these up, x's cancel, the y's cancel, so I'm left with nothing on this side, or nothing is 0, equals 10 plus negative 10 is 0. That's a 0. Now, just like this example, the variables eliminated. However, our remaining equation is true. 0 is equal to 0. Now, once again, if you were to solve for y and graph these, graphically, these would turn out to be the exact same line. This would be the same line. So this one, if the variables eliminate and it's true, that means it's infinite solutions because they are the same line. So that's a quick review about systems of equations. I hope that brought back some memories for you. Smith out!